Dear students, today I am going to discuss about the module 4 and 5, that is from 4th semester engineering mathematics. Module 4, that is sampling theory and stochastic process. In this the contents, let us make a note on these contents, what this chapter exactly explains. That is, in the sampling theory we discuss these topics, that is sampling, sampling distribution, standard error, test of hypothesis for means, confidence limits for means, students t distribution, chi-square distribution as a test of goodness of fit. Next, in the stochastic process topic we discuss the following: stochastic process, probability vector, stochastic matrices, fixed points, regular stochastic matrices, Markov chains, higher transition probability, and simple problems. What we do with the application point of view by studying this topic in 4th semester engineering, we come across many situations in the engineering as application problems. Huge data we come across, such that the data which is to be finalized, whether the data is to be accepted or to be rejected, the criteria which we are going to apply by making the analysis in the form of sampling, and then generalization of this sampling, and then taking the final decision according to the mathematical procedure. What is that mathematical procedure? First of all, in the sampling theory, that is huge data we consider it as the total sample, that is total population, and a small portion of that we call it as a sample, and then method of choosing like this, taking a sample in the whole population, that is huge data, which will be, the process is called as sampling procedure, that is sampling theory, and then analyzing a simple sample which is taken from the large sample, and then we test the criteria for testing purpose, and that testing purpose will be done by various means, and that will be followed by the concepts of statistics and probability. First topic deals with sampling theory, has the contents sampling, sampling distribution, standard error, test of hypothesis for means and proportions, confidence limits for means, student t distribution, chi-square distribution as a goodness of fit. Let us define basically what do we mean by sampling. Sampling theory is the field of statistics that is involved with the collection, analysis, and interpretation of data gathered from random samples of population under study. The application of sampling theory is concerned not only with the proper selection of observations from the population that will constitute the random sample. Sampling aims at gathering maximum information about the population with the minimum effort, cost, and time. Sampling determines the reliability of these estimates. The logic of the sampling theory is the logic of induction, in which we pass from a particular sample to general population. Such generalization from the sample to the whole population is called statistical inference. Here I would like to clarify what do you mean by the specific meaning of statistical inference. That means, to make decision process, we take a sample. For example, in this room itself, we take a sample of the atmosphere at some corner, and then we draw some conclusions from that sample which we have drawn from the whole size, and then we give some decision making results based on the probability formulations, and process of doing every sample in the whole population will be leading to certain conclusion. So, this process is called statistical inference. It also involves the use of probability theory along with prior knowledge about the population parameters to analyze the data from the random sample and develop conclusions from the analysis. The normal distribution along with related probability distributions is most heavily utilized in developing the theoretical background for sampling theory. Dear students, probably you may be knowing that normal distribution. So, you have studied in probability theory, because in every topic some preamble is required. That preamble, let me remind you, regarding normal population here. So, related probability distributions is most heavily utilized in developing the theoretical background for sampling theory. Theoretical distributions, as you know that there are three theoretical distributions. What are those theoretical distributions? Means the first one, binomial distribution, and second one, Poisson distribution, and third one is normal distribution. You need to remember the details of these three distributions for what purpose we are going to use. That means in a statement, that means in some data which has been documented, whether it is related to, for example, we are studying in engineering course, maybe it is an engineering data, fine. That data will be explained for certain inputs and the corresponding output. Certain inputs, corresponding output means like x and f. That means x and f means x stands for the statistical variable, means as an input, and f is nothing but number of observations in that particular input of x. We call it as a frequency term. Then when such is the case, like here x1, x2 and so on, here f1, f2 and so on, then how this binomial distribution plays a role for our present sampling theory. Here this is conclusions from the analysis. That means the data, the normal distribution along with related probability distributions is most heavily utilized. Among these three, we are going to use normal distribution, but the binomial distribution and Poisson distribution are giving certain results like given frequencies and expected frequencies. Similarly, in the normal distribution, that is also there are some frequencies given and new frequencies we are going to obtain. What is the role of this normal distribution in the present study? The role of normal distribution in the present study, which takes, because the word itself, the word normal itself gives an idea, it is called symmetrical distribution. Symmetrical distribution means, for example, in this room itself, when I stand like this, to the right of my right side and left side, if I allow the equal magnitude, equal length, then it is called normal distribution, otherwise symmetric distribution, otherwise equal distribution. Suppose I stand here, then more items are lying towards one side, it is called oblique distribution. That is, more items are lying towards one side, and it is not called as normal distribution, because maximum values of the given data will be plotted on the basis of normal distribution. Then we try to draw some conclusions in this normal distribution. The data is to be decided, its parameters are to be decided, whether that data is to be accepted for further process or it should be rejected. And normal distribution will help us to take such decisions in two types of statistical ranges. One is 5% level of significance, and one more is 1% level of significance. For that, further topics in the next few titles which we are going to discuss as confidence limits and then testing the hypothesis. There we are going to discuss, but what is the role of this normal distribution? Let me explain. Anyway, in the case of binomial distribution, already you know that is P of R is equal to NCR Q to the power n minus R and then P to the power R. What is this P and what is this Q? Already you remember that is P is nothing but probability of success and Q is nothing but probability of failure. Then, so P of A, this is followed by binomial coefficients, that is NCR, and this is these two are called discrete probability distributions, and this is called continuous probability distribution. And in the case of Poisson distribution, same PR, this PR is called PDF or PMF. This is called probability density function or probability mass function. In Poisson distribution, PR e to the power minus m to the power r divided by r factorial, where m is nothing but the constant of Poisson distribution. The constant of Poisson distribution, there are two constants in each distribution. Binomial distribution has two constants, that is one is arithmetic mean, that is n into p. N is the given size and p is the probability of success, and sigma, this is standard deviation, square root of it is npq. And in the case of Poisson distribution, the same constant, because we are going to use in sampling theory, then in Poisson distribution the first constant x bar equal to m and sigma is equal to root of m is there. And in the case of normal distribution, how we are going to utilize for our present requirement? In the case of normal distribution, we have the normal distribution curve like this. It is called bell shaped curve and symmetric distribution, and we give two ranges for these values. One is minus 1.96, that is towards negative x axis, and this is plus 1.96 and 2.58 with minus and 2.58 with plus sign. So, this is one range where we are going to consider at 5% level of significance the data is to be analyzed, and this range, outside of this range, that is 1% level of significance. Then in this way, normal distribution will help us when you have used data and when you are going to plot that data as a normal distribution curve, then whether it comes between 1.96 minus sign and 1.96 plus sign, or it will come within this minus 2.58 and plus 2.58. These two values are standard values from practical point of view we consider in the case of normal distribution. Then whatever the data is there, that data we are going to compare with the standard normal variate by the calculation of standard normal variate in this normal distribution, that is called z, and the same x axis will be called as z in terms of x. Then this must be x minus mu then divided by standard deviation, otherwise x minus x bar, that is divided by sigma, because x bar stands as arithmetic mean of the sample, and mu, this is also here also we use mu, that is representing the mean of population. This is mean of sample and mu is mean of, that is population. Then standard deviation as usual in the denominator we write. So, we calculate with the help of this standard normal variate the coordinates of z, that means values of z we calculate, and then we will compare whether it lies within this range or outside of this range. So, related to this, some definitions we are going to discuss again. What is the meaning and objectives of sampling? The meaning of so far we discussed about sampling theory, but now the meaning of sampling is, sampling denotes the selection of part of the aggregate statistical material with a view to obtaining information about the whole. As I told you some time back, we take a sample. For example, a factory produces certain capacitors which will be used for practical purpose in some laboratory. Capacitors, then all the capacitors we are not going to check. Few capacitors will take, and then their configuration and the calibration and all other requirements we will check from that one, and then we can generalize the articles which are produced by this factory for the practical purpose can be accepted or it can be rejected. If this sample gives the idea which comes the decision making of these ranges, then we can accept at what level of significance. We can accept at 5% level of significance or 1% level of significance, like that. Only these two are the categories which we are going to compare, and that sample is decided that it is of good quality or it is having all configurations which are going to be satisfied for the practical purposes, then the whole sample, whole size of the material will be selected. So that we endorse like by checking a small sample. That is what the meaning of the sampling. Sampling denotes the selection of a part of aggregate statistical material with a view to obtaining information about the whole. Means information about the small item, and we are going to generalize about the whole item, like that. Then there are two words we are going to discuss and we are going to apply in our discussion. One is population or universe. This is the terminology we are going to use in the complete discussion of this sampling theory, that is population or the universe. For example, the population of India, population of our country, whatever the total population is there, we call it as universe, but in statistics universe or it is the population. For example, a sample of few human beings we consider in our state Karnataka or some population in some other state in our country, then it is called as a sample. Then we will see the behavior through these statistical conclusions parameters, then we will generalize. Then if this sample is giving good results, then the whole population we have to take statistical inference. Then population means the aggregate or totality of statistical information on a particular character of all the members covered by an investigation is called population or universe. Then sample, a selected part which is used to ascertain the characteristics of population is called sample. What are the characteristics which we are going to ascertain in the sample? There are two characteristics which we are going to ascertain. One is that is mean of that, and the other one is standard deviation. Then why these two parameters we are going to check? Normally this arithmetic mean in every calculation in the part of statistics and probability plays a major role. Why it is so? Because suppose we take x as the statistical variable, as I said in the above table, this one, then for example x takes the values x1, x2 up to x10, there are 10 values. What is the mean of this? Then we will be writing x bar is nothing but sigma x divided by small n. Here that is n is equal to 10 because total number of values are there, and it will be written as x1 plus x2 plus so on plus xn divided by, it is 10 is there. Here sigma notation, sigma of x is there. Even some authors you will find like sigma I equal to 1 to 10, here xi, like that. Some authors will recommend that suffix. Even if you do not write suffix, but whatever the total number of values are there, you are going to add them and dividing by number of values of x it is given. Then you are going to calculate some numerical value. Anyway, that is a simple logic, you know that. Simple logic means, for example, 1 and 2 numbers. Here this is x1 and this is x2, that x takes the values. What is the mean of these two? Easily you can write it as 1.5. Then what is the mean of 1, 2, 3? Easily you can write it as, that is middle number, it is 2. This is in the case of even number of values and this is in the case of odd number of values. Fine. What exactly this indicates? What is the purpose of studying this x bar arithmetic mean? Everywhere we are going to utilize the application meaning of this x bar. For example, in the statistics, so many topics you have studied under the heading as basic statistics. What are those? That statistics part involves measures of central tendency, measures of dispersion, skewness and kurtosis, correlation and regression, rank correlation, and then curve fitting. All these chapters you are already familiar with these things. Yes, everywhere in all these calculations, everywhere you have taken x bar as the calculation as arithmetic mean. What is the significance? What is the role of that x bar? X bar tells us the behavior of how the data is centrally to the central position, how the data is clustering at the central position. For example, when I stand here, I can explain the behavior of the items to my right side, and also I can explain the behavior of the items towards the left side. That means how those items are coming towards the central line, the behavior of this type of values. When the values are coming towards the central line, behavior of this type of values which are arranged, it is called a measure of central tendency. Measure of central tendency, and the opposite meaning. So all those measures of central tendency you have studied as 5 statistical averages. You are familiar with that. First is arithmetic mean, second is median, third one is mode, next one is geometric mean, and last one is harmonic mean. Then if you think in an opposite way, for example, when you stand here, instead of the behavior which is coming from both the ends towards the central position, if the items are how they are scattered from the central line towards both the ends, it is called measures of dispersion. So those values, measures of dispersion, will include the first one as the first calculation as range in the case of measures of dispersion, next is quartile deviation, next is mean deviation, and next one is standard deviation, and another one is root mean square deviation, RMS. So these 4 values are there. Here for sampling theory, from the first chapter, that is measures of central tendency, we take the help of x bar, 2 parameters mainly we are using, and from measures of dispersion, that is standard deviation value we are going to take, that is sigma. Then the sigma explains the deviation in the given series of the particular item from that location, how it is deviated. For example, in the whole sample, you are given certain articles which are produced by some machine. Then those articles are to be finalized whether they are of good quality or not of good quality. Then we will choose a sample of that, and then we will take the decision over that sample which we have chosen, and then we are going to give the conclusion about the complete size of that particular item. Then suppose there is a small deviation, whether it is due to the manufacturing defect or any other reason, there is some deviation, then that part will take into further analysis, and then we will rectify that particular discrepancy. Therefore, these 2 parameters, arithmetic mean and standard deviation, will play the major role in making decision process for further consideration or rejection. Then here this is x bar is central value, and then standard deviation is for the same series how the property is going to be deviated, like that we take. Then what are the symbols for these two we are going to use? For the population, the symbol in all the testing equations, that means formulations which we are going to use for further study, population size always will be represented by capital N, and sample size always will be taken as small n. Now, there are two main objectives of sampling. What are the two main objectives of sampling? The first objective is to obtain the maximum information about the population with the minimum effort. That means maximum information of the population about the population with the minimum effort. With the minimum effort we will take the help of mathematical parameters such as arithmetic mean, standard deviation, and also the errors which we come across as type 1 error and type 2 error. That means here more information which we are going to gather from the population, that is capital N, by making minimum effort. What, in my opinion, that minimum effort means you must know the background of the interpretation of arithmetic mean and the interpretation of the standard deviation respectively for two behaviors. One is the data is coming, all items are behavior of the items are which are clustering towards the center line, that explains the numerical value of x bar, and the another one how the items are scattered from the center line, that is nothing but standard deviation parameter we are going to use. Main objectives are the first one is to obtain the maximum information about the population with the minimum effort, and the other one is to state the limits of accuracy and estimates based on samples. That means limits of accuracy, what I said some time back, I was telling this is the limit. For example, minus 1.96 and plus 1.96, one limit, and the another limit is minus 2.58 and plus 2.58 on the z axis, both towards positive direction and negative direction. That means why we are using these two values? Immediately your question may be there like that. Why we are using? Because practically these two ranges have been accepted at level of significance levels will be respectively. This is first one is 5% and second one is that is 1% level of significance, because for most of the practical applications we use these ranges as common criteria for decision making process. So only to state the limits of accuracy of estimates based on samples. This is the second objective of sampling. Next, in the same line, what are the types of samplings we are going to discuss? That is, first one is random sampling. Random sampling, how it will be done? Here sampling must be random. That means, for example, some time back I was telling a machine produces certain articles. That means there you can choose the sample from the whole articles in a batch sample. Randomly you can choose, not like suppose if it is arranged like 1, 2, 3, 4 up to, for example, 100 items are produced by a machine, then you are not supposed to take like 1 up to from 1 to 10 or 90 to 100 or somewhere like 10 to 50 like that. Randomly you select. That means some item, that means 1 to 10 one item, 10 to 20 one item, like that, random selection. Otherwise whatever it is there, that is called random selection. Means you must remember, because you have studied all these things and probability, you had taken the application for this, and every problem includes in the probability with the condition that it is called unbiased. That means probability concept you must remember carefully, because all those things are very much we are going to use, even though you are defined as P, Q, even some other terms like that. Next comes all these details, but what is the basic condition for addition theorem, multiplication theorem, and then conditional probability, and then it is generalized as Bayes theorem. Therefore, in all these occasions problems we are going to choose in every probability value calculation in the form of numerical value, we put the condition as unbiased. Unbiased means impartial. For example, if you toss the coin, If you toss the coin means that coin, when you toss the coin, that coin should not lie perpendicular to the ground. It must lie parallel to the ground, so that on the upper surface we can see either head or tail, like that. That is called unbiased situation. So here random sampling will be done, that is random items are selected randomly, not with particular intention you are going to select. Maybe with that if you insist that condition, intention means if it is a good quality, only you will take the good quality and you will declare it is of good quality and the whole lot to be accepted. No, that is not the answer. Here random sampling means you have to take randomly the items which you have to select and then give your opinion. That is called random sampling. Even as you are already aware, in the probability decision making process, tossing the coin, then throwing the die, and drawing a card from pack of playing cards as 52, and drawing a ball from a bag where the bag contains various colors of balls, like that. That is done with this word, imposing with this word unbiased. For example, when I throw the die, you know that die means it is 6-faced cube, right? 6-faced cube. On each surface dots will be there. Dots will be there, like 6 dots. Backside one more is 6 dots. When you throw the die, it must clearly show on the upper surface any one surface from 1 to 6. Okay, and clearly you must see, and not the other surfaces you have to see. That is called unbiased condition. So we put the unbiased condition means it is selection should be at random. It is not with any particular intention. It is the method of selection of a group of units in such a manner that every unit comprising the population has an equal chance of being included in the sample. That is what the meaning which we have written, and that is the expansion I have given. I have given the expansion in a blow up details. Random sampling, for the word first sentence is sufficient. Here sampling must be done, must be random. That is what. Next is purposive sampling, where when the sample is selected based on the individual judgment of the sampler, it is called purposive sampling. That means some sample one judge will be take and the judgment he is going to give, and that is recorded. Similarly, other sample will be done and his judgment will be given. Similarly, third person will take the sample and his judgment will be given. Likewise, if you go on documenting these judgments, means acceptance or rejection, like that. And quality wise, then quality and quantity, of course both we will have to discuss, but in statistics and probability more about we talk in the form of quantitative measurements. When the sample is selected based on the individual judgment of the sampler, it is called purposive sampling. As I told you that each judge will give his own decision, then all of them should be documented. That is with purpose. Purpose means those documents, those judgments which are documented are to be further analyzed properly. Next is stratified sampling. In this, the population, as I told you that capital N, population means the whole item, and it is subdivided into several parts, and these several parts which are subdivided from the whole population, they are called as strata, and then subsample is chosen from each of them, then all the subsamples combined together give the stratified sample. That is, subsamples when you arrange, that means it is not like random selection from the population, that means from the capital N you are going to draw the sample. It is arranged in the form of subdivided into several parts, and then you are going to choose each subdivided sample from which is already arranged, then you are going to test it. For example, easy to understand, like if a factory produces certain goods and then goods are arranged in the form of various boxes. One box you are going to take and then test whether that box contains the good quality items or not. That is to be tested. Then you are not going to mix the items which are kept in bag box number 1, box number 2, box number 3, like that. No, each box will be tested separately. Its conclusion will be documented. That is called stratified sampling. And next one is systematic sampling. It involves the selection of sample units at equal intervals after all the units in the population have been arranged in some order. When earlier to this definition I was discussing about the stratified sampling, there boxes were not arranged in some order, but here the condition is those boxes must be arranged in some order. For example, if the box contains the goods which are manufactured by that particular machine about 10 days back and 9 days back, 8 days back, now 1 day back and today, like that. If you arrange those boxes and then you are going to allow these items which are kept in the boxes and you are going to test, and this will be leading to the properly arranged boxes, and then you are going to test. This is called systematic sampling. Whether you start with the box number 1 or you start with the box number 10 and coming back to 9, 8, 7, 6, 5, 4, 3, 2, 1. Otherwise, you are going to start with 1, 2, 3 up to 10, like that. If you take your sampling procedure and giving the decision either in the increasing order or in the decreasing order when it is properly arranged, that is called systematic sampling. Then multi-stage sampling, it refers to the sampling procedure which is carried out in several stages. That means one sample one-time sampling decision making process is done, but it is not the end of the procedure. That means it will be tested once again. For example, in the first sample testing, some decision you have taken and you are not satisfied with that, then and you yourself will have some confusions or you yourself will have some doubts over the decision what you made over the first box, for example. Then you are going to test it again. Test it again means with the same procedure or with small changes in the procedure of testing. Then you are going to select second box, and if you come across the values, that means everywhere we are going to test means there are some numerical values according to some mathematical formulations. We have testing procedures. In the next few details I may explain about the testing procedures. As we know that testing will be done by student t distribution, chi-square distribution, f distribution, like that. Then using those equations, each equation has got significance in giving decision making. Then for example, in the first box we are going to use some kind of formulation and then we are going to give the decision. Suppose you use student t distribution, you are going to give some conclusion, and then if you are not satisfied, then you will take some modification in the same selection procedure and then you will give the decision for the second time. That will be far better when you compare with the previous calculation, that is numerical value. This is called multi-stage sampling. These are all the different types of sampling: random sampling, purposive sampling, stratified sampling, and systematic sampling, and then multi-stage sampling. And further explanation in this, how these sampling decision making process will be done under what parameters. As I told you already, arithmetic mean, standard deviation, and will be called as statistical parameters, mainly will be used to test the sample from the whole population. So these two parameters will play the major role in making decision process. Then the next important concept is sampling distribution. What do you mean by distribution first? That means distribution means, as I told you, the data is arranged in the form of this type of table. For example, that is the input as a statistical variable and the output always we call it as f. This f will be among these three, any one of these three we are going to put, like PR. Then PR it may be for binomial distribution, PR it may be for Poisson distribution, PR it may be for normal distribution. Then which one you are going to use to fit the given data according to binomial distribution or according to Poisson distribution or according to normal distribution with a specific size of the item. That size of the item means what is that size of the item? When you are given these values, f values, and if you take a total of this, that means sigma f we are going to take. This is called size of the item, that is the capital N, means sum of the frequencies. That in the form of definition, it is the probability law which the statistic follows if repeated random samples of a fixed size are drawn from the specified population. The probability distribution of the statistic of the mean of x values will be called as sampling distribution of sample mean. That means this distribution is analyzed through probability calculations, that means numerical value, that is sampling distribution. How many types of distributions are there? We have two types of sampling distributions. One is sampling distribution of sample mean, that is x bar. Sampling mean means x bar. Here that bar symbol should have been written, that is a correction is to be made. And if x denotes the mean of random sample of size sample size n drawn from a population with mean mu and standard deviation as sigma, then the sampling distribution of x is approximately a normal distribution with mean is equal to mu and standard deviation, that is called error of that x bar. Then further explanation, that is with finite size of sampling, with finite size we define the sampling distribution. Then standard error. This is another parameter in the sampling theory we are going to use. The standard deviation of sampling distribution is called standard error. So only I was telling, this standard deviation plays a major role from the given data, where that particular data takes the deviation, and the study of such deviation from the given sample will play the major role. Then this standard error will be represented for giving some proper precision of the practical data. That means reciprocal of standard error is called the precision. Mathematical calculation we take like that. Then how this decision making regarding sample size we are going to make. If n is greater than or equal to 30, a sample is called large, otherwise it is small. This is some range it is suggested, that means some stage we have selected for practical applications. When it is greater than or equal to 30, a sample is called large, otherwise small, that means less than we can call it. And next is testing the hypothesis. So far I have been telling like the sample which is going to be selected from any total population, and we are going to test with certain hypothesis. What is that hypothesis? Here this word plays a major role, that is testing the hypothesis. Suppose I take a sample and then I put my hypothesis with confidence. For example, what confidence? When I selected this sample, for example, here one factory produces a certain textbooks, that means one machine produces certain textbooks. Then I assume that these textbooks are textbooks means all the information and contents and then quality of the paper and everything. If it is good, then I will put it as, let the product from this company, let the product from this machine which is produced by this machine will be of good quality. If it is of good quality, then we will accept. There are certain formulations, and those using those formulations we will get some numerical value, and that numerical value to be compared with the standard values which are already available in the table. Then we have to take some decision for the hypothesis which we proposed, and with that hypothesis we have to choose whether this quantity as a sample which you have taken, whether it is to be accepted or it is to be rejected. The process involved taking a sample and then testing and then giving a decision, and then in terms of the numerical value giving a decision is called testing the hypothesis. Hypothesis is nothing but some assumption or some expectation we propose. You can propose the quality is not good, that is one proposition. Quality is good, you can propose another proposition. Any one of these two, either like yes or no. If it is yes, then whatever the proposition you give, that means assumption or claim you give, if that claim, if through calculation, if that numerical value is going to support your claim, then you will say that the given item which is for testing, it is to be accepted or it is to be rejected. There are numerical values from the actual calculation to be compared with the table of values. That is the procedure. Then this method consists in assuming the hypothesis as correct and then computing the probability of getting the observed value. If this probability is less than a certain pre-assigned value, the hypothesis is rejected. Pre-assigned value, here that is what I was telling. Pre-assigned value means this is available in the table. For example, student t test, there is some formulation, and then chi-square test, there is some formulation, and f test, there is some formulation. But all these three, t, chi-square, f, this one is t, this one is chi-square, and this is f. Each one has got the equation, right? All these three are called a statistic in the sampling theory we are going to use, and t has got its own standard values, that is t distribution table, and similarly chi-square has got standard accepted values. We have got chi-square distribution table, and similarly f table. Then the formula which you are going to use, either from t test or from chi-square test or from f test, the numerical value finally what you got by the actual calculation for the given statement of the problem will be compared with the table values. If that lies from the table values less than that table value, then for in some cases we are going to accept it, and if the value of this t is greater than the table value, in some cases we are going to reject it. But everything is based on what the hypothesis you are going to propose. Based on that hypothesis, that you are going to take your own decision. And next, what are the sometime back I was telling that standard error, but now statistical errors we are going to discuss. There are two types of errors, type 1 error and type 2 error. Here the important meaning lies in the first definition, that is type 1 error. For example, when I claim my hypothesis, that means my claim is I assume that this data sample is of good quality, the first hypothesis. Then you are going to give some decision. In this decision making, for example, if you have your own doubt, no, this data should not have been of good quality, but your claim is it is good quality. The difference in your claim among your own mathematical calculation is called type 1 error, and type 2 error, whatever the first type 1 error claims are there, then opposite type. For example, in the first case type 1 error, if you are going to claim let this sample will be of good quality, then after the decision is given it should not have been good quality, like that. In the type 2, let this sample is not of good quality, then after the mathematical calculation you will assume that, or you will claim that, oh, it is of opposite type, like that. So the difference and the ambiguity which you are going to come across, it is written as type 1 error and type 2 error. In the next discussion, I will explain about mathematical calculation of this type 1 error and type 2 error.